Welcome to a new video on section 5.2. So section 5.2 is about graphs of polynomial functions. It's also about evaluating polynomial functions, but we'll do the evaluating part in class the next time we meet. So if you were in class on Wednesday for periods A and B or Thursday for periods D and F, we did an exploration activity about end behavior for polynomial functions. So the hope is that this video will reinforce some of those things that you explored the last time we met as a class. So we're going to look at a few examples. So first example we're going to look at is y equals 2x to the 4 power plus x cubed plus x plus 1. So the first step that you want to do for these kind of problems is to determine the end behavior. Remember, the end behavior is basically arrows point in what direction. So we look at the leading term, which is going to be 2x to the 4 power. We notice that we have an even degree, this right here being called the degree, right? And we have a positive coefficient, this right here being the coefficient. So when we did the expression activity, we noticed that the graphs that have a leading term with an even degree and a positive coefficient, that both arrows point up, which kind of would make sense because if you were plug in a positive number for x, you'd see that y would be positive. Likewise, if you plug in a negative value for x, y would still be positive. And as x gets more positive or as x gets more negative, y is only going to get more and more positive, just by the nature of the term we see here, 2x to the 4 power. So our second step will be to plot a few points and graph. So now we expect both arrows to be pointing up, and it probably would help to make a quick table. And I suggest maybe 3 or 4 x values might be good, like 0, we'll try 1, we'll try -1. Maybe we'll try 2 to see how that looks. But if I plug in 0 to this function, I see that y is going to be 1. If I plug in 1, I should get 2 plus 1 plus 1, I should get 5. If I plug in -1, gotta be a little careful here. The first term will be 2, but then -1 cubed is -1. So we should get 3. And what the heck, I'll try 2. That's going to be a pretty big number. If you do 2 to 4 power, it's 16. 2 times 16 is 32. 32 plus 8 is 40. I think we get 43. Good luck in plotting that. But if I make a few tick marks, and it'll change colors. And I'm going to erase these red arrows because they're not exactly in the proper location, but the graph will probably look something kind of like this. Remember, this is just a sketch. It's not quite accurate, but at least we have some points, and we have the arrows pointing in the right direction, and that's what really matters. When you get to pre-cal, you'll start making these graphs a bit more accurately, and then calculus actually will be pretty spot on, some of the skills you'll learn in those courses. So right now we're kind of just scratching the surface. So let's look at one more example, and then we'll be done with the video. So example number 2. Let's try graphing y equals negative x cubed minus 4x. And yeah, actually let's make it plus 4x. Okay, so we're going to graph that. Now if we look at this one here, our leading term, actually let me fix that. Is negative x cubed. That's an odd degree with a negative coefficient. So if we think about it, if I were to plug in a large number for x, y would be negative, right? If I plug in a negative number for x, y would be positive. And remember, the leading term always dominates all the other terms. The other terms totally pale in comparison to the leading term. So now I make a table. If I plug in 0, I get 0. If I plug in 1, I should get 3, I think. If I plug in, say, 2, interestingly, I get 0. And let's try negative 1. I should get negative 5. So now we make our plot, or plot our points, so we sketch our graph. So 0, 0, 1, 3, 2, 0, negative 1, negative 5. So we know the arrows have to go like this. Again, odd degree, arrows in opposite directions, negative coefficient. And again, when we figure that if we plug in a positive value for x, y is negative. Based on what we see here, if we plug a negative value for x, y should be positive. But it does look kind of interesting because when I'm plugging a negative value in for x, it looks like it's going to be pointing down. We want it to be pointing back up. We want it kind of like that. So when I plot my graph, I'll probably do something kind of like this. And I'll have it come back up. And here we have our graph. By the way, I'm not sure if anyone noticed, but you can actually factor this. You can factor out negative x to get x squared minus 4. And you would see that the zeros would have to be 0 and plus or minus 2 if you set the equation equals 0 and solve for x. So we see that this graph should cross 3 times. Also, we notice that it's degree 3. That means that you have at most 3 possible zeros. That's something we'll kind of explore a little later in this unit. But that would be our sketch. So we'll have a chance to practice this next time we meet as a class. And I'm just starting to think right now that I may have accidentally said earlier in this problem that when x gets negative, y gets negative. That's not true. When x gets negative, y is going to be positive. When it gets more and more negative, that's what I really mean by that. Not at negative 1, but like at negative 10 or negative 100. So like a large negative value. Okay, so we're all set, and I'll see you guys later. Goodbye.